Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Similar Shapes, Finding the Missing Measure. Alright, follow along with me here as I read this opening information out loud. Similar shapes are different sizes but have congruent angles. You can set up a proportion to solve for the unknown measure of a side. Now, in case you forgot what a proportion is, it is when you set a fraction equal to another fraction where both fractions are set up the same way. I'll show you what I mean here with our first couple examples. All right, the directions say each of the following diagrams contain two similar shapes. Write a proportion that could be used to solve for x, and then do not actually solve it, because I just want to introduce you to the idea of setting up a proportion, two fractions set up the same way. This is meant to be really, really easy. If you make one of your fractions come from the measurements of the first shape, and then make your other fraction come from the measurements of the second shape, then this is going to be really easy. Let me show you what I mean. Problem number one. We have this slightly bigger triangle, followed by this slightly smaller triangle, and these triangles are meant to be similar triangles, meaning their angles are exactly the same, just one's a slightly bigger version than the other. So, the easiest way of doing this is by looking at the measurements here of the first triangle. We got 23 meters and x meters. 23 meters is obviously the small little side that's almost horizontal, and x is this much longer side that is here on the right. So I'm going to make that my first fraction. And then I'm going to set it equal to a fraction set up the exact same way, but using the measurements from the other shape. So you can see the 23 corresponds, meaning it's the same type of side as the 18 meters, and the x meters is the same type of side as the 62 meters. So if you set up your first fraction as 23 on top and x on bottom, then our second fraction needs to be 18 on top and 62 on bottom. If you set the second fraction up the opposite way of the first, then it would not be correct, and setting them equal to each other would actually be totally wrong. So you have to set up both fractions the same way. Now, do you have to make the first fraction 23 on top and x on bottom? Actually, no. If you wanted to put the x, which is the right side, on the top of the fraction and 23 on the bottom, then that's fine. But then you have to set up the second fraction in the same type of way. So since the x is this long right side, and we put that on top, then 62, which is also the long right side, must be also on top. And then since 23 corresponds to 18, and we put 23 on bottom, 18 must also go on the bottom. Both fractions must be set up the same way. Problem number two. Can you try it on your own? Hit pause real quick in the video, try it on your own, then hit play to see if you got it right. Okay, did you already do number two? If you put 12 over 16, which is the left side over the bottom side, then you should be setting that equal to the left side over the bottom side from the larger quadrilateral. Or if you put 16 over 12, since 16 corresponds to 25, then 25 would also have to be on top. And since 12 corresponds to x, then x would also have to be on the bottom. Either proportion is correct. You don't have to write them both down. I'm just showing you both just so we can cover the two different ways that kids would write this. Oh, by the way, if your first fraction is the second fraction, and my second fraction is your first fraction, that's also totally fine. Does not matter which fraction you write first. Does not matter. Okay, problem number three. This is what we're actually trying to get to. Writing the proportion and then solving it to find the measure of x. So let's start by writing a proportion. 60 over 55 is the way that I would like to do it. Equal to, now we have to set up the second fraction the same way. Since 60 is this left side touching the single arced angle and the triple arced angle, then we got to find the same side here. Well, it's also the left side, 48. So we're going to put that on top, just like we put 60 on top. And since 55 is the bottom, touching the triple arc and the double arc, then x, also touching the triple arc and the double arc angle, would also be at the bottom. Now, could you have rebelled? Could you have put 55 over 60? Yes, but then you have to put x over 48, since 55 corresponds to the side that's called x, and 60 corresponds to the side that is 48. Now, to solve a proportion, you might be like, how do I do that again? Well, let me show you. What you can do is called the cross products rule, where you cross multiply. The 50 gets times to the x, and the 55 gets times to the 48. 60 times x, write it on the left side. 60x equals, use your calculator if you need to, 55 times 48 would give you 2,640. Keep the equal sign in between, just like you had the equal sign in between to begin with. And then do the inverse of multiplication, which is clearly division. Do it on both sides. That'll give us x by itself. Right side will give us, calculator time, 44. And we are talking about the measure of feet here, if you look at the original drawing. And there you go. Now, that's not the only way of solving a proportion. Write this down again just one more time. There is a shortcut. If you can figure out a way of multiplying something to the numerator that gives you the other numerator, then you can multiply that same something to the 55 to get the value of x. Now, you might be like, well, how would I know what I would take 60 times to get 48? Well, sometimes it's obvious, like if it's timesing by 2 or 3, or maybe even 1.5 or half. But in this case, it's not so obvious. So in your calculator, if you divide going backwards, you'll get what you multiply going forward. So in your calculator, take 48 divided by 60. Do that right now. You should have got 0.8. And since you divided backwards, right to left, to get that 0.8, then you can multiply going forwards, left to right. And then we can multiply that same thing times 55 to get the value of x. And it works. Now, do I always recommend doing the shortcut method? No. In fact, on this problem, I probably would have never thought of doing the shortcut method if I didn't instruct you guys to go ahead and try it. But sometimes they're really obvious. Like sometimes to get from the one numerator to the other, or from the one denominator to the other, because sometimes x is on top. It's not always on bottom. So sometimes you're doing this kind of strategy with the denominators to figure out what to multiply the numerator by. Anyway, sometimes it's really obvious. Sometimes the numbers are twice the amount of the other or half the amount of the other. So sometimes it's really obvious. And when it is, I totally would do the shortcut in that situation. All right, let's just do one more together real quick. We got next page, problem numbers 1, 2, 3, 4, and 5. Each of the following diagrams contains two similar shapes. Find the value of x. I'm going to go ahead and write the first fraction as 6/9 equal to, hit pause real quick, set up the second fraction in the same way as the first. Did you already do that? You should have had 8/x. Now, if you did 9/6, then you would have had x over 8. You don't have to write that down, but that is an alternate way of doing it. And then, is there an obvious shortcut here? Maybe not. If this was a 12 instead of an 8, then the trick is just multiplying by 2. But I don't really see that here. You could do 8 divided by 6 and get a multiplier, and that would be fine if you want to do it that way, although I think it's 1.3 repeating, if I remember correctly. Not really easy to do a repeating decimal in your calculator, but I guess you could have done like 1 and 1/3. That would have worked. Anyway, I'm just going to go ahead and cross multiply. X times 6 is 6x. 8 times 9 is 72. Divide by 6 on both sides. If I'm going too fast, hit pause in the video, catch up here. And that should give me 12 feet. So I think you should be able to get the hang of this now. Hit pause in the video. Do 2, 3, 4, and 5 on your own. Now, don't go further than that. Don't do 6 yet. That's a different ball game. We'll get to that one a little bit later. But try 2, 3, 4, and 5 on your own. And then hit play once you're done with those problems and are ready to see how you did. So hit pause now, 2, 3, 4, and 5, and then you'll hit play once you're done. Okay, have you already done 2, 3, 4, and 5 on your own? If not, hit pause, because here I go. Let's check our answers. You could have had x over 12 equals 15 over 18, or you could have had them flip-flopped. And again, if my first fraction is your second and my second fraction is your first, that's totally fine. If you do the cross products rule, you got 18x and 180, divide by 18 on both sides, and you get the answer of 10 meters. Now, there was a shortcut here. You could take 12 times 1.5 to get 18, and then divide, since you have to go the opposite way. If you take 15 divided by 1.5, you would also get the 10. So if you used a shortcut and it worked out for you, congrats, that's fine. Problem number 3. You probably did 14 over x equals 21 over 24, or maybe you did x over 14 equals 14, or sorry, 24 I meant to say, over 21. Cross multiply. By the way, it doesn't matter which side you had them on. They might have been on different sides if you used the alternate setup that I was talking about. Divide by 21 on both sides, and you get 16 centimeters. You could have done a shortcut of taking 14 times 1.5 to get 21. Then you would divide by 1.5 to get from 24 to 16. So if you did a shortcut, that is fine. Problem number 4. I would totally do, spoiler alert, I would totally do a shortcut on this problem. You're about to see why. You probably did 10 over 8 equals x over 16. Or maybe you did 8 over 10 equals 16 over x. And hopefully you realize to get from 8 to 16, you are multiplying by 2. So this is the time that I would definitely recommend doing the shortcut. You wouldn't even need a calculator. If you did the cross products instead and got 160 equals 8x, fine, still works. I wouldn't mark it wrong, but this is a problem where I would definitely recommend doing the shortcut because it's just so obvious. And problem number 5. You probably did. X over 18 equals 35 over 30, or maybe you flip-flop them. 18 over x equals 30 over 35. Probably did the cross products rule on this one. Maybe not. Maybe you did a shortcut instead. If your shortcut led to the same answer that I have, then fine. You're good to go. Your work doesn't have to look exactly like mine if you found a shortcut method that worked for you. Okay. If you need to hit pause or rewind on any part of this video, please feel free to fix your mistakes if you made any mistakes. Moving on. Problem number 6. I want to lead you through this one together because this is a unique type of similar triangle situation. The triangle on the right is actually kind of upside down from the one on the left. Let me show you what I mean. If you look at the angles here, this is a single arced angle, and this is a single arced angle. Notice how they're at opposite places. Here it's on top, here it's on bottom. And same thing with the double arced angle. Here it's actually on top on the smaller version of the triangle. So it's kind of like taking the first triangle on the left and rotating it 180 degrees to get the triangle on the right, but then it's a smaller version on the right. So you will have some drawings like this. In fact, spoiler alert, there's a problem coming up that's really similar. So just be aware of that. So the 24-inch side, which touches the triple arced angle and the double arced angle, actually corresponds to the 14, which also touches the triple arced angle and the double arced angle. So if you're like, I'm looking for the side down here, the PO, no, you're not. QO actually corresponds to NO. So that's how this type of drawing works. So follow along with me. Let's set up a proportion. If you do 15 over 24, the sides from the larger triangle, the 24 corresponds to the 14, so the 14 should also be in the denominator. And as you would expect, the 15, which touched the single arc and double arced angle, would correspond to the x, which also touches the single arc and the double arced angle. And there you go. You also could have done 24 over 15 and 14 over x. Either way is fine. I'm going to go ahead and do the cross products rule. 15 times 14 is 210. 24 times x is 24x. Divide on both sides and you'll get 8 3/4 if you did a mixed number, or 8.75. Either way is fine. Inches is your unit of measure. I think you will be able to do problem number 7 on your own. Now, I didn't put the arcs on the angles this time, but number 7, very similar type of problem to number 6, except instead of having the bigger triangle on the left and the smaller one on the right, this time the bigger triangle is at the bottom and the smaller triangle is at the top. Similar problem, though. Let me jump ahead of number 8. You'll eventually go back and do number 7 on your own. But let me talk about number 8. This is when you have a triangle inside of the bigger triangle, but the two triangles are similar. So check this out. We have this small little triangle inside, and there are two measurements given to us. The x for this top part of the side, and the 20, which is this right side. and then that is inside of the much larger triangle that has the sides that you see marked here of 46 and 34. So you could actually draw those as two separate triangles. The large triangle had sides 46 and 34, and then the smaller triangle had sides of x and 20. And redrawing it can definitely help you to see what sides correspond to what. Do I think you always have to redraw it? Maybe not. But if you're getting confused, if you're looking at the original drawing and you're like, I don't know what side corresponds to what side, then maybe drawing it as two separate triangles would be very helpful. Okay, I'm not going to set up the proportion for you. I believe now that I've redrawn it for you, you will be able to see what fraction to set equal to what fraction and then cross multiply and solve or do a shortcut method. Number 9 is a similar type of problem, except the smaller triangle, the left side is the person's height. So you got this tiny little triangle on the bottom, and then you got the much larger triangle that makes up the entire thing. Okay. Time for you to finish up this page on your own. Don't forget to go back to 7. It's similar to number 6. And then finish up number 8. I already started talking you through it. And then also do problem number 9. So hit pause now. Finish up this page, 7, 8, and 9. Then hit play once you're ready to see how you did. Okay, have you already done 7, 8, and 9? If not, hit pause, because here I go going over the work. Number 7, you probably have a 25 over 36 and an x over 64. If you have your first fraction as my second and my second fraction as your first, totally fine, does not matter. You could also do 36 over 25 and 64 over x. Again, doesn't matter which fraction is first, which fraction is second, does not matter. If you do the cross products rule, actually, yeah, I would probably do the cross product. I was thinking if this was 72, then it would just be 2 times. Divide by 36 on both sides. You get 44.4 repeating, or 44 and 4/9. You might remember 0.4 repeating is 4/9 yards. If you did a shortcut method and got the same answer, that's fine. You don't have to do the cross products rule if you don't want to, if you can think of a shortcut. All right, problem number 8. Your proportions were 44 over 34. Did I say 44? I meant to say 46 over 34 equals x over 20, or flip-flop them. That would also work. Cross products and then divide. Not a pretty answer. If you got the decimal version, I would totally recommend making it the mixed number. You probably have an F to D function on your calculator if you have a Texas Instrument calculator that can change that ugly decimal into the mixed number, because otherwise you have to find out where the decimal repeats. And this was, I think, more than a 6-digit repeating decimal, so really hard to see where it repeats on most calculators. And I don't want to round. The directions did not tell me to round, therefore you should not round either. You could also use your fraction key instead of the division key. You could hit 920, fraction key 34, and then enter, and it will make it a mixed number for you in simplest form. So try not to round when the directions do not tell you to round. Instead, do the mixed number version unless you can see where the decimal part actually repeats. Then a repeating decimal would also be fine. And finally, problem number 9. You're either doing 280 over 210, and then the unknown side, which you can call X or H for height, or G for the height of the girl, or T for how tall. I don't care what letter you picked. I just picked generic X for that height of the girl, over 3.75 for the distance of that shadow, or you could flip-flop them. Same thing. Cross products rule probably on this problem. And divide, you'll get, a nice whole number answer of 5 feet for the height of the girl. And that finishes up the guided notes called Similar Shapes, Finding the Missing Measure. Thank you for watching. We'll see you next time.